So let me introduce to you our next speaker, Maciej Norberciak. Maciej works in Nokia, where he's primarily a software architect, but he's also a trainer and a mentor. He holds a Ph.D. in computer science in the area of artificial intelligence, but has worked in the telecommunication industry ever since, taking part in projects on various embedded platforms as a programmer, designer, architect, and project manager. His favorite pastime activity is learning. Anything goes. His speech is Quo Vadis embedded. Let's welcome Maciej on stage with a big round of applause.
Thank you. Great to be here again, talking about embedded systems again. Should I see this here? No? Oh, okay. So first, let's have a quick show of hands. Who of you, pun intended, is embedded in embedded? So if you are a software developer, architect, designer, scrum master, whatever. Wow, a lot of embedded people. So, spoiler alert, if you don't want to wait till the end of this presentation, you are in a good place. But I was not so sure due to some experiences I had earlier this year. I started to question my chosen career path. I will describe just two of them, one from each side of a barricade, so to speak. So, as an experienced guy, I tend to do some trainings, very embedded trainings, like effective use of programming languages in embedded systems or software design patterns for embedded systems. And as the groups on those trainings are, well, mixed, we start each training with getting to know each other by introducing ourselves. And we do it like that. My name is Joe, I have many years of experience, my primary target platform is based on ARM microcontroller, and my primary programming language is Python. Python, really. Don't get me wrong, Python is a fine language, but in general, it is ill-suited to embedded applications. Most applications tend to use some other languages, but I started to get that kind of answers more and more often. But I also had experiences from the other side of the wall. A colleague of mine over coffee asked me to guess which processor family has the biggest production volume nowadays. And I had no idea, of course. He read this in some kind of IT journal. I thought maybe ARM, maybe 86, and he told me, no, it's 8051. 8051, really? Who got the joke? Apart from the guy who told me this joke. Okay, just a couple of you. Let me explain. This is 8051. This is an 8-bit microprocessor, and I'm not sure whether this is visible, so let me zoom it for you. This 80 here means that it was designed in 1980. It's a 40 years old chip. And while I was searching for the confirmation of this information about the production volume, couldn't find it, by the way, but I found out that this chip is still widely used in IoT, in automotive, in batteryless devices, RFID cards, styluses, and so on and so forth. Vendors are announcing back and forth new devices, new chips based on this ancient technology. So I started to question myself, where is the truth? Are we, people that are doing embedded software, are still stuck in 20th century, so to speak? We do our ancient systems on ancient platforms using ancient languages, and we fight for every byte of RAM and every byte of code footprint and every processor cycle because we have precious few. Or maybe we, as everybody else, are already in 21st century. And we are using modern tools, modern technologies, modern methodologies. We have powerful processors, gigabytes of RAM. I'm a software architect, so I try to keep the wide perspective of things, but I am susceptible to cognitive biases, like everyone else. And I'm also a scientist, so I needed data, hard data. I started with market research. If you enter this phrase into your favorite search engine, you will get dozens different market research companies, and they will be happy to offer you their market research reports. I ordered a couple of samples and already saw a problem with them. Depending on the company, the estimated size of embedded systems market is between 70 and 170 billion dollars. So there's a huge discrepancy in the definition of what embedded systems market is and what is an embedded system. No surprise. If you look at the definition from books on the subject, those definitions will tell you that this is a computerized system, that is purpose-built for some application, and this is a combination of hardware and software and maybe some other parts, and they are designed to perform a dedicated function. This is a broad definition. It encompasses both such small 8-bit devices like the one I was talking about at the beginning, running no operating system at all, and big devices like, I don't know, Raspberry Pi, gigabytes of RAM, multicore processors, running entire Ubuntu distribution, for example. Both can be considered embedded systems, although tools, methodologies, even programming languages you use to do software on those devices are vastly different. So definition is one thing that you have to remember when you talk about embedded systems. The other thing you have to remember are constraints. And the most important constraint is performance. The more performance you need, the more power you draw. The more power you draw, the more heat you produce. And you need to dissipate this heat. And this is all interconnected. You can trade some performance for memory or the other way around. But again, memory draws power, memory produces heat, and you have to mount all those chips on your PCB, on your printed circuit board. And the size also matters. It's also a constraint. And if you finally want to produce your device in millions of pieces, the most important constraint comes into play, and it's called BOM, bill of materials, the cost of hardware. If you spare just $1 on every device, this is $1 million for your shareholders, and maybe $100 in form of your bonus. Let's hope. But again, this is all interconnected. So coming back to the definition, I don't want to get in the fight about definitions. Embedded systems are things that are purpose-built. They perform a dedicated function. Usually they are part of the bigger system, so they are nomen omen embedded in something. They are constrained, sometimes very highly. And finally, software and hardware for embedded systems are codependent and co-developed. We, software guys, work very closely with hardware guys. On average, in embedded project, 40% of the costs in form of money, resources, people are in the hardware, and the rest 60% is in the software. Sometimes we even fix bugs in the hardware in software. So market research was no good for me because they couldn't agree on the definition of the market. Also, those reports were aimed at investors. So if you have gazillion dollars, you want to invest it in embedded market, here are your key investment pockets, have at it. I'm no investor, I'm a developer, I want developer's perspective. So I turned to developer survey, starting with the biggest one, Stack Overflow developer survey. 80,000 people answered this year. The problem with the survey, from my perspective, is that their favorite language is JavaScript. So again, not a very embedded thing. And there were some information on embedded systems there, but few and far between. It was hard to cut through the noise. The same problem I had with the state of developer ecosystem from JetBrains. You may know this company from very good IDEs they do. 36,000 people responded last year. 75% of them are in web development, so not a very embedded survey. The best one, then the only source of information on embedded systems, state of the union, from developer's perspective is called embedded survey, and it's done by AspenCore. You may not know the company. This is a media company. They own a number of venues that, do embedded. Venues like embedded.com or Electronic Engineering Journal, or if you are Polish, elektroda.pl is also owned by AspenCore. And they do this survey for more than a decade now, not regularly. The last one was in 2019, and in May this year, another one came. It's a good thing, actually, because thanks to this big gap, we could observe some tectonic changes in the environment. More on that later. Just over 600 people responded to this survey, but every single one of them was a verified embedded systems professional, and average experience among them was more than 18 years. So, old, knowledgeable people. Thanks to the survey, I could check first where we embed ourselves, and please note that this is not about the market volume in money. This is about the number of projects we do in certain areas. So the most popular application of embedded systems is industrial control and automation. Then IoT, whatever that means. Roughly 1/3 of embedded systems have something to do with Internet of Things. Then we have telecommunications, networking, wireless, things I personally work in for times immemorial. Then, of course, automotive. Electronic instruments, apparently this is a big application area for embedded systems. Then we have customer electronics. This is probably the biggest market in hard cash volume, because we have home appliances here, we have wearables, we have mobile devices, toys, games, gaming consoles, peripherals, and so on and so forth. Then medical and health applications, computers and peripherals. You have no idea how many individual embedded systems are embedded in your garden variety PC. Finally, military, small and big, and aero space. There are some other application areas like audio, video, imaging processing, security, power generation, utilities, and so forth. Around half of embedded systems are real-time systems, so they have to respond to external stimuli in a finite and precisely defined amount of time. Roughly 2/5 of embedded systems have some kind of analog and all digital signal processing capability. The same amount have some kind of networking or wireless capability. 1/3 is battery operated, 1/3 is rugged or environmentally resistant. Depending on your environment, you can resist your bathroom or you can resist outer space. And finally, 1/3 has some kind of graphical user interface. If you bought such a rugged mobile phone, you have all those most popular capabilities in one package. If you ask embedded developers what are their biggest challenges, they will tell you that, of course, performance is a thing. Then debugging and testing, because we have to do it on real hardware, and it's painful and strenuous and complicated. Then security, and finally, power consumption, power management, energy efficiency, and in consequence, heat dissipation. If you turn to project managers, they will tell you that cost of hardware, bill of materials is important. Equally important are customers' data security and the security of the intellectual property your company is putting in the system they are putting in the market. Both developers and project managers will agree that there is one big challenge that you have to tackle at the beginning of each project, and this is processor selection. So we'll start with that. We'll start with the hardware. And we'll start with processor market. Half of the embedded systems have just one microprocessor. Sometimes it's multicore. But in general, we are not very fast. Embedded systems are somewhat slower than what you are used to with your PCs and mobile phones and calculators. 3/4 of embedded systems are clocked under 500 megahertz, 1/3 under 100 megahertz. Three big areas: 32-bit microprocessors, 16-bit and 8-bit. The question was what processor you use in your current project and plan to use in the next 12 months. So this is not exactly market share. This is some feeling, vibe, direction for the future. So if you look at the survey itself, those numbers will not sum up to 100%. In order to be explicitly mentioned in the survey, in case of 32-bit processors, you needed to gather over 6% responses. And there were 24 different devices that managed to do that. So you can see that this is a fragmented competitive market. And 15% of responses were other devices. Top three are ARMs, and in general, most of those things that qualified to be mentioned are ARMs of different shapes, sizes, and colors. But this doesn't mean that other architectures like AVR32 or MIPS or other exotic things do not register on the radar. They do. What hasn't registered, so it's under 6%, is RISC-V, and I will talk about RISC-V in a minute. But now let's shift to 16-bit. In 16-bit, this market is even more fragmented. In order to be explicitly mentioned, you needed to gather at least 3% of responses. 12 devices qualified, almost 40% are others. Those top 5 are PIC. PIC is eternal. Then Texas Instruments, it's a good thing you're sitting. I've checked on Texas Instruments webpage, and they are producing 572 different versions of this device. 572, mind-blowing. ST Microelectronics has a foothold in all the areas, always. Then we have NXP offering. They say that this is a legacy microchip, but this is so loved by automotive that they still produce it in numbers, and it's still very popular. Finally, 8086. 45 years of history behind this chip. Finally, 8-bit area. In order to qualify, you needed 1% of responses, 17 different devices, and more than one-third are others. Again, competitive, fragmented market. PIC on the first place, AVR, hello Arduino, of course ST Microelectronics, why not? ATXX, the thing I was talking about at the beginning, and finally trivia time. Apparently Zilog Z80 is still in the game. With 4%, if you don't know what Zilog Z80 is, this is a chip that propelled the revolution of microcomputers, 8-bit microcomputers in 1980s, being a basis for such fine devices like this, ZX Spectrum, or Amstrad Schneider, or Elvro 800 Junior, and many others. So where is RISC-V? RISC-V, open architecture, open standard, open ISA. Instruction set architecture. Open means cheap. You don't have to pay the license. If you want to do ARMs, you need to pay license to ARM consortium. In RISC-V, you just take it and do it. So no wonder all the big ARM competitors and customers support RISC-V International. By the way, if you are to remember just one thing from this entire lecture, please remember that this is RISC-V, not RISC-V. I've been told this is a great fit for embedded. I have no personal experience with RISC-V, but I've been told modularity and portability and power efficiency features and flexibility, they are great for embedded. So why it hasn't registered on the radar of this survey, although apparently, ostensibly, it is gaining momentum for a couple of years now. Well, I can make just some guesses, opinions. Those are not hard facts. Those are just things I think about when I think about RISC-V. First, if you have a standard, an open one especially, there's a question how far you can push the standard and still conform to the standard. And you may have devices that are compatible but still need different software. But I don't really think this is a problem, because if you do ARMs, you know that ARM ecosystem, software ecosystem, is extremely fragmented. x86 ecosystem is also extremely fragmented. I think the problem here may be politics. You see, as this is an open standard, China has declared RISC-V their national chip strategy. And politicians have noticed, especially American ones. And they say things like, you know, China is using our Western intellectual property in order to, you know, wage war on us technologically, and not also, only technologically. The fact is that China does not want to be, you know, dependent on Western technology, Western licenses from Intel, from ARM. So they support this open standard. But I think that thanks to our American colleagues, this may not be that open in the future. Okay, if you have chosen a processor, you have to make another choice. Do you want to start your projects from development board? So you have this processor, you have some memory, some peripherals on a PCB that you bought off the shelf, yeah, a ready-made thing, and you learn to program this processor and those peripherals on this development board. Or you start your development already from the prototype, the first and hopefully the last, it's never the last, hopefully the last version of your target system. And for the past decade or so, those approaches were equivalent. 50% started from dev boards, 50% from prototype. But something has shifted in those past 4 years, since 2019. Right now, 75% of projects start from development board. And although this number hasn't changed, 1/3 of them are some kind of proprietary custom-made thingy. This is interesting. 1/4 of embedded systems start their development from Raspberry Pi, and another 1/4 from Arduino. This is interesting because those things started as hobby offerings. Yeah? Right now you have like 100 different versions of Arduino, 15 or so Raspberry Pi, not counting all those, excuse me, industry-grade Raspberry Pi. Why? Why, for example, we want to use Raspberry Pi? As a target platform, especially if you want to produce your device in huge numbers, this is somewhat expensive. The cheapest one is $35 right now. Your accountant will tell you to cut it in half, for example. But if you just want to put it on each developer's desk, it's not a problem. It's cheap. $35 is peanuts. This platform is rich in resources and peripherals. It has multi-core processors, it has gigabytes of RAM, it has USBs, Ethernets, HDMIs, Wi-Fi's, whatnot. You probably don't need all those things. But it's a good approach to development, not only to embedded development, but in the development of software in general, that you make your system working first and then you optimize. Well, it's a good platform as any for making such things. And finally, I mentioned hobby. I have 2 Raspberry Pis at home, and I don't know how many Arduinos, and I tinker with them. You know, I use them to scratch my geeky itch, and hundreds of thousands, if not millions, of people around the world do the same thing. So, if theoretically I needed another job and went to a company that uses Raspberry Pi or Arduino as the development board, I'm already prepared. I know the tooling, I know environment, I know some tricks, so I can be productive faster. So it's no longer a hobby. And also you can buy industry-grade Raspberry Pis, you can buy computing modules based on Raspberry Pi. For industrial control and automation, this is a good fit. Produce in low numbers, you have a platform that is battle-proven, and there are multiple open source software offerings for the platform. Latest news from, I don't know, 10 days ago, 2 weeks ago, ARM has bought a stake in Raspberry Pi, and this is very interesting. 7 months ago, Sony did the same thing, but Raspberry Pi is a paying member of RISC-V International. So, again, makes you wonder what will happen with RISC-V now. To sum up the hardware situation, I would say nothing has changed since I started embedded systems. So we invented green before green was popular because we want to use as little power as possible. Also, we invented hardware reuse and reuse in general because this number is actually staggering. From project to project, there is 80% of reuse of hardware or intellectual property connected with the hardware. So, you know, we started in 1960s with this chip, and we are still using it now because we love it so much. Huh? It's just cheaper to do the same thing over and over again because your people are experienced with this ancient technology. And of course, we do cheap because our companies are apparently not run by developers. They are run by accountants. I remember I was doing this IoT project, and for our target platform was supposed to be dual core thingy clocked or 200 megahertz, if I remember correctly, but we ended up with one core and 60 megahertz clock. So yeah, cheap matters. But from the other hand, you don't need some sophisticated microchip in order to, you know, run a toaster, unless this is a very complicated toaster. But again, who needs such a thing? Okay, software. If you are an embedded developer with some experience, and no matter what your target platform is, your favorite primary programming language was, and always will be C. 52% of embedded projects are primarily coded in C. Yeah, in your face. Why? The answer is very simple. Code reuse. C is here to stay because from project to project, we have 90% of code reuse in an average embedded system. It's just incredible. Also, C, although this is an old thing, it's a stable standard and it's living. I think in 2 hours there is a lecture about the newest standard of C. I've heard in C23 they introduced two new keywords, true and false. So they are very conservative when it comes to doing this standard. If you have book by those two gentlemen, Kernighan and Ritchie, C language, if you know this book, you can work on embedded systems, although it was written 35 years ago. If you don't want to write in C, you can write in C++. It has fallen from 22 or 26% from 2019. The rest is peanuts. Python, Java, 5%. LabVIEW, assembler, 4th, more embedded things than Python and Java, 3%. Go, C#, Lua, very not embedded things, 2%. Hobby, prototypes, but not really production things. Every time I do those lectures here on embedded, people ask me about Rust. Where is Rust? Most loved, most admired language, according to the Stack Overflow Developer Survey, by a long shot for past 10 years. Most loved and most admired. We love it, but we don't use it. Why? And please don't hate me. This is a hard fact. We don't. Why don't we use it? I can make some educated guesses. So silicon vendor code, first and foremost, is written in C. And from the reasons I've already described, will be written in C in perpetuity. They are big conservative companies. They have a huge code base dating from, Pleistocene or something. Yeah? So they will be doing this in C still. Everybody knows C. Sadly, if you want to learn Rust, you probably have to do it on your own because there is very little support from universities when it comes to learning Rust or Rust proper. Then this may be a factor if you are working in a big company. Big companies tend to, have conservative management because they need to, they take care of shareholders' money. And Rust apparently has no serious standard. Of course, if you know Rust, you know that this is standardized. And if you read through the Rust standardization practices, you will see that those are state-of-the-art. But this is not ANSI, this is no ICCC, there's no serious organization behind Rust standard. So yeah, I don't know. Finally, quite a big chunk of embedded systems are safety critical systems. And in order to be certified, so you need a piece of paper that says, yes, this system is safety critical system. In order to get certified, sometimes you need to use a secure coding standard. And there are secure coding standards for C, ancient ones, and for C++, even more ancient ones. Forget about anything that happened after 2014. But there are secure coding standards for those languages. There is even a secure coding standard for Perl, I was told. But there is no secure coding standard, established one for Rust, sadly, although this is a fine language and a secure one. Finally, you remember those numbers I've shown you on microprocessors market, that this is very, very, very fragmented. And I looked through the Rust compatibility table, and many architectures, many microcontroller architectures are not really supported by Rust compiler yet. So in order to gain a foothold, I would say that you need to support all those things that are on this huge and extremely fragmented market. What will happen with Rust? I don't know. It's gaining momentum, but I hear this gaining momentum for the past 10 years. So yeah, 2%, sorry. Some zealots, fanatical zealots of embedded systems say that if your system runs an operating system, this is not an embedded system proper. So 3/4 of embedded systems are not embedded systems proper because they have some kind of operating system. And it has risen actually in past 4 years. Interestingly, 81% of people that do not use operating systems said that they do not need one. So I'm wondering what, because I couldn't find the answer, what the rest, this 19% says. I need an operating system, but I'm scared and my religion forbids me to use one. Anyway, 60% of the OSs we use are open source software operating systems. Out of that, 1/3 are commercial distributions, and 20% of the systems we use are purely commercial operating systems. When we buy something commercial, we want documentation, we want support. We pay and we demand. Still, 20% are proprietary things, and basing on my limited experience, I would say that those are those ancient, venerable things. In my first job as an embedded developer, we had this real-time operating system that was written when I was still in primary school. Well, of course, we made fun of it, but one thing was certain. This thing just worked, so why change it? Why, rewrite it in a different language, like Rust? Again, this market is very fragmented, and you will see it in a moment. But if you ask yourself a question, what system should you use? The answer is, of course, Linux. You can use Linux, or Linux. But Linux is not the only one. There is not really a competitor, because this is a different animal. But there is one system that from 2011 is either together on the first place with Linux or on the second place, and this is FreeRTOS. Amazon Web Services has invested heavily in FreeRTOS. Great community, great system, easy to learn, easy to master, I would say. So truly recommend, but a very fragmented market nevertheless. 19 responses gathered over 4% and were explicitly mentioned. 7% of answers were others. If you ask an embedded developer what are the most important design techniques when it comes to producing software. He or she will tell you that simulation, emulation, and modeling and visual prototyping are the best. Translating it into plain English. We want to do software for hardware, but we don't want to touch this hardware. As much as possible, we don't want to get in contact with hardware. And in consequence, we do things a little bit more waterfally than an average software developer is used to. If you look at Agile Manifesto, there is this passage that we prefer working code over comprehensive documentation. But we in embedded systems, we do a lot of documenting, modeling, simulation, upfront design before we start coding something. So, yeah, we are not very agile, at least in my experience. It's not the most important thing on our radar. Okay, I think I rushed it a little bit, but we'll maybe have some more time for questions. The future, my friends, is bright. No matter which company does the market research, they all agree that in next 10 years, embedded market will grow, and it will grow twice. Right now, on average, embedded developer does more than 4 projects a year and has 2 projects or more than 2 projects at his or her plate at the same time. And this number is steadily growing for the past decade. So there will be more work, and this will not be taken over by AI because ChatGPT apparently can't solder yet. Yeah, seriously, I've tried to do some embedded coding with the help of AIs, and they do not do embedded yet. They do not do FreeRTOS. They lie very, very well about it, but no, not yet. And of course, you know, someone has to connect the cables at the end, so they can't do it yet still. But AI is there. Roughly 20% of embedded systems have some kind of AI capability on board, whatever that means. It can be just hardware acceleration for AI. But if you look at the Gartner hype cycle, AI is on the peak of inflated expectations. So I don't really know where it will go from now, but again, I would risk an educated guess that it will go down, and there will be a lot of disappointment. Our life with advances in emulation, simulation, and modeling techniques will be easier, hopefully, but in the end, we will need to, you know, debug and test our software on real hardware, and it will not get much easier. Okay, things like remote debugging were just a pipe dream 20 years ago when I started my career, but right now this is a norm. But still, sometimes you need to, you know, sit at your desk with your hardware and talk to it. Yeah, learn C, or learn to love C, embrace C, because C is here to stay for foreseeable future. We will write things in C, or maybe C++. And yeah, love legacy, because of this code reuse, which is huge in embedded systems, and because 50% of the projects we do are just new versions of old projects. But the rest is new and exciting, and I cannot wait to get into it. Okay, thank you very much for attention. A bit of shameless self-promotion. If you read Programista magazine, I've written an article on the same subject, more things inside. This edition, I think it will hit the newsstands in a few days. Okay, thank you very much, and I can take some questions now.
great lecture. Okay, right now it's working. Thank you, Maciej, once again for a great lecture. If you have any questions, just please raise your hand and our volunteers will come to you with the microphone.
Hi. You mentioned you devoted a whole slide to Rust, which is arguably a C++ killer. But what about Zig, which is arguably a C killer? Has it come to embedded yet?
What?
Zig, the language Zig.
Never heard of this, sorry.
Boo.
No, it's not like I want to make laugh of you, but I haven't heard of it, simply. Well, I would say C is good enough.
I would like to ask, you mentioned that majority of embedded systems projects are made in C, and I am aware that some companies try to shift towards C++. How do you see the future of C++ in embedded? Could it maybe be on a loser position due to some performance issues? Because so far I've heard that C++, when applied correctly, has basically no performance disadvantage in comparison to C. However, I would like to hear what is your perspective on the future usage of C++, especially considering that C++ at most part is backwards compatible with C.
So first, I fully agree with the statement that when applied correctly, C++ has no bigger footprint or lesser performance than C. This was designed to be on the par with C, and as far as I know, it is. As for the future, if you look just at those embedded service, well, the C++ has fallen, but whether this is a trend that it was rising for a couple of years, then it was falling. Whether there is a trend here, hard to say, because those studies are few and far between. What is my feeling? Well, those are different animals. C, as I said, is simple. It's a stable standard. It's not a large thing. There are some new things introduced in the standard, but I would say not many people use them. The compiler support is there, but still. But I remember when they introduced, I think, growing arrays in C standard. Immediately, Linus Torvalds has said that using them is actively stupid, so nobody uses them. C++ is a behemoth. It's gigantic, and there are multiple features there, and it's much easier than in C to shoot yourself in the foot, because there are so many things that you have to comprehend, to master. In embedded systems, you have to understand how your code translates into the machine code. And if the language base is so huge, sometimes you have no idea what's behind all those libraries. Yeah? So I don't know. C is just more complicated, harder. And there are some things that bring benefit to embedded developer in C++. There were a number of lectures about C++ in embedded in past years. So you can check them on YouTube, I think. But also there are things that are not really beneficial, but create more RAM footprint, ROM footprint, and so on. So you have to be careful with C++. Where it will go, I have no idea. I'm primarily a C developer. My background is in C. I did a lot of C++. I still teach C++, effective usage of C++ in embedded. But whether it will grow considerably and will push out C, I don't know. Sorry.
What about the main concern of people when approaching C or C++ both, which is memory safety? In C++ we have features like smart pointers, we have pretty easy implementation of RAII in terms of classes. However, on other side, I've heard opinions that using dynamic memory allocation in embedded systems, especially safety critical embedded systems, is plain stupid. So how that fares?
Okay, so in MISRA, I think, secure coding standard, I think it explicitly forbids using dynamic memory allocation. So it depends on your system, depends how much resources you have. I remember one time I looked at the actual implementation of one of the smart pointers, and it was like 50 times bigger than a normal pointer. But it's not easy to answer this question because this ecosystem of embedded systems are so huge, and there are systems which are highly constrained, and you have to turn off everything, including standard library, if you want to fit your program into memory. And from the other hand, you have huge systems where you can benefit from all those, well, convenience features. Like, I love smart pointers. It's a great idea to have a smart pointer. But yeah, depending on your system. So as every answer, modern psychologists will tell you, I can tell the same. It depends.
Okay, thank you.
Okay, thank you very much. I think that you can catch up with Maciej during the break, right? Is it correct? Maciej, will you be able to answer additional questions there?
I will hide for a moment, but in general I will be available here.
Okay, another big round of applause to you. Thank you very much.